Our focus standard for this lesson comes from grade 7, Expressions and Equations, Standard 4B, Solve Inequalities and Graph the Solution Set. Our topic comes from Simplifying Expressions and Equations, Inequalities with Negatives. Our essential question is, how does multiplying or dividing by a negative value affect solutions to inequalities? Please take a moment, pausing the video if you need to copy down the topic and essential question into your header, along with today's date, sub your question column and your note column, and resume the video when you're ready to begin. So we've been looking at inequality statements and learning how to solve them, and so far we have done only one type of problems, and we haven't done any that involve negative values. So a couple of reminders. One, always inspect your solutions to ensure they are reasonable. So really kind of test in a few values to make sure that your statement seems to make sense. And if not, check for one of the following things. So if you multiply or divide by a negative value, you must flip the inequality sign. Now the reason for this goes back to when we learned to multiply and divide by negatives. We learned that multiplying or dividing by a negative flips what side of the number line we are on. And since we flip to the opposite side of the number line, we must also flip the inequality sign to make sure that our statement still is reasonable. So we're going to look at 4 examples today that have us practice and look for this type of problem. Let's go ahead and look at our first example. For our first problem, we are going to look at negative 4y plus 10 is less than or equal to 22. Now, we're going to just follow the exact same steps as we had been that we used to solve equations as well as inequality statements. So you'll know to draw a line down the middle, dividing the left statement from the right side of the statement, and then just continue with the same type of procedures. So let's go ahead, pause the video, and go ahead and try out the first few steps, and then resume the video when you're ready to compare and discuss the problem more. So the first step is going to be to subtract 10 from both sides. That is the term without the variable. Since we're adding 10 to the term negative 4y, we're going to do the opposite and subtract 10 and do the same thing on both sides. Doing so, we should end up with a statement that negative 4y is less than or equal to 12, since 22 subtract 10 is 12. Now, to separate y from negative 4, since this is a multiplication step, we're going to do the opposite, which is to divide by negative 4. And we're going to do that on both sides. Here we talked about multiplying or dividing by a negative, so anytime you catch yourself doing that, that should be a red flag for you. And when we divide by that negative 4, we get y on the left, and 12 divided by negative 4 is negative 3. Notice that I have also switched my inequality. I was using the less than and equal to symbol, and now it is the greater than equal to symbol. And that is because I had to divide by a negative 4. If you look closely, this is what I was talking about. This was a negative term. Negative 4 times y, that was a negative term. And this, on the right, this 12, is a positive term. And after having divided by negative 4 on the right, this 12, which was a positive term, is now negative. So that's what this dividing by a negative flips us to the other side of the number line, and so we must flip our inequality symbol in order for the statement to still be true. So our final answer is y is greater than or equal to negative 3. So if you haven't done so, go ahead and try graphing it on the number line. So graphed out, we should have a closed circle on negative 3, and since y is greater than any value or equal to, we filled that circle in and highlighted it to the right on the number line. So any of these values plugged into our variable will make this a true statement, and you can definitely test that out and try it in both directions and make sure you have convinced yourself of that. Let's move on to our second example. Number 2, we have the statement negative 36 is less than or equal to negative 20, subtract 8c. Go ahead and draw your line dividing the left and the right. Start following the steps to solve this inequality and check back when you are ready to compare your work. So the first step to get that negative 8c by itself would be to add 20 to both sides. Doing so, negative 36 plus 20 gives us negative 16 is less than or equal to negative 8c. Since c is being divided by negative 8, we are going to divide both sides by negative 8. Again, that dividing by a negative should be a red flag to us that as we complete this inequality, we need to flip our sign. So dividing by negative 8, negative 16 divided by negative 8 gives us 2. We get c by itself on the right, and notice I have flipped my sign. It was facing less than or equal to, and now I have it as a greater than or equal to symbol. So I just flipped it over because I divided by negative 8. So our final solution is 2 is greater than or equal to c. What is that solution going to be on the number line? Well, if you have a filled in circle at positive 2, and since when we start with the variable side, we read it that c is less than or equal to 2, you highlighted everything to the left and 2 on the number line, I would agree. Let's try number 3. Let's try number 3. 12 plus h divided by negative 5 is greater than negative 1. Go ahead and pause the video here to solve this inequality and graph it on the number line. You might remember from our work with equations that we can think of this group up here on the fraction bar, that's a grouping symbol, keeping that 12 and h together. So we first have to undo the dividing by 5. The opposite of dividing by 5, negative 5, is to multiply by negative 5. So we're going to do that on both sides, which is going to leave us with the statement 12 plus h is less than 5. Notice that the sign flipped because right here in our first step, we multiplied by a negative 5. So that is super important to pay attention to. We have our flipped inequality and we're ready to continue. Since this is a positive 12 and we want to do the opposite of that to get h by itself, we're going to subtract 12 from both sides and we get the statement that h is less than negative 7. Graphing that on our number line, we would have an open circle at negative 7. And since h is less than that, we have highlighted everything to the left of the number line to represent this inequality. Number 4. Mr. Nays has saved $1,000 to build a pond in his backyard. He wants to keep at least $300 in the savings. If he withdraws $100 from that savings every week to work on his pond without making any deposits, for how many weeks can he make withdrawals? Think about this math story and see if you can come up with an inequality that would represent that so we can find an answer to this question. The inequality that I wrote in this problem is 1,000 minus 100w is greater than or equal to 300. Let's talk about why that works. So here's that $1,000 that he saved, and he's withdrawing $100 per week to work on that pond. Since he's withdrawing and having to take that money out, and he always wants to keep what's left, right? This is representing the 1,000 minus the withdrawals. We want to keep that above, greater, or equal to 300. That's because that's the lowest he wants it to go. So this inequality represents the word problem we have here. So if you haven't done so already, go ahead and solve this inequality. Interpret your solution to write your answer in a sentence, and graph it on the number line. So instead of going step by step, I'm just going to show you that my steps all together for solving this inequality. So hopefully we agree, but if you have any questions, please write them in your question column and come ready to discuss more problems like this in class.